Hi, I'm back again, and we're again going to look at the Fibonacci problem, and this time I'm going to tighten the screws down a little bit tighter with additional flow of control logic. And in fact, I'm going to use some additional flow of control logic along with a function that's built into JavaScript called the chaAt function. So I'm going to have to explain how that works here in just a moment. Okay, so let me run the program, then I'll come back to this diagram, then we'll look at the way the program works by analyzing the program code. So looking at Fibonacci sequence demo 3, and I want to open it with a browser. And when I put in a number like 12, it will work fine. Okay, now this text box needs to be expanded a little bit, so trust me, it overflowed the text box. And let me reset this thing and put in a value of 5. Okay, so with a value of 5 it works. If I put in a value of 6, do the same thing. Okay, put in a value of 7. Okay, so you see that I'm not trying to pull anything over on you. And 1, 2, 3, 4, 5, 6, 7. Okay, so give you a second to examine that, and what you should find is that it's basically doing what we said it would do before. If I put in a number like 1, it's going to still enforce this rule and tell me the parameter's out of range. If I put in a value of 21, okay, parameter out of range. And if I put in a value of 3, that will work. If I put a value of 19 in, it's going to overflow that text box, but you'll see that it still works. All right. So I'm enforcing that same rule that I did before, but this time if I put in a value like R2D2 and attempt to use that as a limit, hey, I'm a human being. I'm perfectly capable of making some kind of input error up here. If I do that, it comes back and tells me the parameter is not a number. Okay, so I'm testing not only to see whether or not the input is within the range greater than 2, less than 20. I'm also checking to make sure that the input is a numeric value. And how am I going to do that? Well, let's take a look at the diagrams first. What I'm going to need to do is look at every single character, individual character of input. So if I had something like 12, it would be stored the way you see it here, as a 1 preceding a 2. If I had R2D2, it would be stored in a manner similar to what you see now. Get this right. D2. Okay. So R2D2. Okay. That's the way that would be stored. You know what? R2D, I'll get it right. I'm going to confuse you yet. Okay, so R2D2 would be stored like this. Now, what I want to do is I want to examine every single character, because I might have something that looks like this. 1, 2, Z2. And the first character would be fine, second character fine. That Z might be embedded somewhere in there. Could be any character. What I want, though, again, is I want a stored value that is in the range of greater than 2, less than 20, and I want every character that makes up that stored value to be a numeric character. And so I'm going to scan the parameter value character by character to make sure that all the characters are numeric. And to do that, I'm going to have to use this chaAt function, which allows me to drill down into the stored value character by character. and I will compare it to each individual character to a property called not a number, nan. Okay, so again, a built-in feature of JavaScript. Now, this chaAt method actually is going to be associated with my input object, my parameter value, and it is going to access the individual characters by whatever value I specify within brackets. So if I want to look at the first character, then I would want to look at uplimit.chaAt0. If I wanted to look at this last character, I'd look at uplim chaAt3. Okay. And in fact, if I set up a loop and in my for loop I use an index variable and initialize it to 0, then rather than having to specify 0 or 1, I could simply plug in anything that represents a 0, like my index variable, which is exactly what I'm going to do. Alright, so I'll be using a variable in place of a numeric constant as I access each individual character. Also, something I need to point out is there is a length property associated with these input objects, and that length property is counted with a initial value of 1. So if I want to know how many characters there are in this variable, then in this case, if I store 1, 2, there would be 1, 2 characters. The length would be 2. If I continue on with 3, put something else in here, 5. Now I use 4 character positions, and my length value is 4. Now, why do I tell you about this? Because I can use the length property as the limit for my loop. So I don't necessarily have to know how many characters that parameter is going to contain. I can simply let the system determine that by checking its length property. All right, so we'll see the details of this here in a moment. Just understand that my input parameter can be examined character by character. I have the ability to do that by using this chaAt method, and I can point to the individual characters by whatever I place within brackets. That could be a numeric constant, or it could be a numeric variable. In my case, I'll use a numeric variable. Also understand that that overall structure has a length property associated with it, and that length property value is calculated from a base of 1, 1, 2, 3, 4. So my character position is calculated from a base value of 0. My length property is calculated from a base value of 1. There's a little inconsistency. You just have to keep that straight in your head. Okay, so what we will find in the program that I've written is I have 3 major flow of control structures in sequence. The first one is going to be a for loop, and contained within that for loop will be a single one-way decision. After that flow of control structure concludes, we're going to see that I have a simple one-way decision structure, completely independent, but it follows in sequence. And then completely independent of that, we'll have one more flow of control structure, and that will be a decision structure with a loop in it. And in fact, that may look familiar from the very first diagram because I just copied and pasted it. In this part of the function, I will be generating the sequence if I can prove that character by character, every character is numeric, and if I can also determine that the character value of the input property is a value between 3 and 19 inclusive. So I've got to do 2 tests, and if the 2 tests turn out okay, then I can go ahead and generate the sequence. Now, I'm fairly certain you'll be backing up, watching this video a time or two, so the first time you hear me explain this, it may not make a tremendous amount of sense, but once you see me work through all the details and review it 2 or 3 times, then hopefully everything's going to be good. Alright, so let's take a look at the program code. Here's my program, and if I right click and view page source, I'm going to see the usual stuff at the beginning. Okay, so that needs no explanation. I have revised my function, generate Fibonacci sequence, and as you can tell, it just contains a lot more program code. I told you there were 3 major flow of control structures. There's 1, there's 2, and there is 3. Okay, so there they are. Now let's take a look at what we're storing here. And what we're storing is a value that is provided through the form. Okay, so my parameter value comes from the form when the function's called up. I have the same variables that I used previously being declared, fib1, fib2, fibout, and curfib. Okay, and if you followed what was going on previously, all that should be review. I've added one more variable called isGood, and it will contain either a value of 1 or 0. Now, what isGood is going to do logically is behave like the I guess the American justice system. Okay, so I'm going to set it to a value of 1, meaning innocent, and if I find it guilty of something along the way, namely that the input parameter has a non-numeric character embedded in it, or if I find out it's out of range, if either one of those things occur, then I will, through some decision logic, set it to its guilty state. Okay. Now, if it manages to go through this loop and check each individual character and find that each individual character is numeric, it will never get into this if structure. Let me say that again. I'm going to go through this loop repeatedly, 1 time for each character. I'm using upLimit.length as my upper limit to control how many times the loop iterates. So I'm going to go through character by character. Start with the first character, check the first character, then the second character, and the third character. And every time I check it, if I find there is a numeric character, then it will stay out of this if statement. But if I find that the current character is not a number, and there is a JavaScript function called isNan, which allows me to check to see whether something is not a number. If I find out that that character is not a number, then it will change isGood to 0. All right, but hopefully if I've entered in numeric characters for every character position in my parameter, it will check it and it will fail this if test, and if it continues to fail the if test, then eventually it'll fall out of the for loop, and isGood will still be storing a value of 1. At which point the next completely independent decision structure occurs. This is a one-way decision, but I'm performing a compound conditional test to check the upper limits, so I check to see whether these 2 things are true. So I check to see if the upper limit is less than 2 or if the upper limit is greater than 20. You'll notice I'm using an OR operator this way. Okay? If either one of those are true, then it's going to get into this logic and set is good to 0. Now this is similar to what I did in the previous example, but I used an AND operator previously. Now I'm checking to see, is the upper limit out of range here, or is the upper limit out of range here? If either one is true, then whether it's true true, true false, false true, it'll take the true path of the if and flip is good from 1 to 0. So again, I prove it guilty at that point if either one of these conditions evaluate true. And then eventually what I do in my last decision structure, and this is the one that is going to either generate the limit, either generate the sequence or not generate the sequence. If I find that it clears this hurdle and all the characters are numeric, if I find that it clears this hurdle and that the value I've input is within range, then is good should still be evaluating true, and so it would take the if path on this one-way decision structure and begin the process of generating the sequence. And again, I see that I did this kind of inefficiently. It's a matter of copying and pasting code. That line right there, to be very efficient, should occur immediately after the end of the for loop. Okay, so it'll work this way, but it's just not all that efficient. All right, so here we go. If I enter in, let's say, an example of 12, okay? So if I enter in an example of, if I enter in a value of 12 through the form and I pass that to this parameter, then it declares all these variables, doesn't initialize anything here, make note of that, and sets is good equal to 1. I make a call to another method right here just to clear out the form so that every time I run this, it's going to get rid of anything that might have previously been output during a previous execution of the program. So it clears the form, and then it is going to for however many characters there are, input.length, for however many characters there are, it is going to check each character individually. So the first time through, I has been initialized to 0, and 0 hopefully is less than the upper limit. So we would drop in here and we would check the character at position 0. We would be checking the character right here at position 0, and if that character is not a number, then we drop in here, fire off a message and say it's not a number. If it is a number, it simply ignores this and goes to the bottom of the for loop, in which case comes back up, increments I would have a value of 1 as we start the second iteration, and it would be looking at character position 1, okay, looking to see whether it is not a number. Seems kind of strange to test is not a number. I think it may, you may have to ponder that for a moment. But we check to see if character position 1 is not a number. If it is not a number, then we're going to go ahead and fire off a message, not a number, and otherwise we ignore it. And it's going to go through every single character for however many characters there are in the parameter. We give every character position a a test, and if it contains a bad value, a non-numeric character, then it's going to get into this if statement and it's going to set is good equal to 0. If all the characters are numeric, it never gets into the true path of the if, and therefore it will wind its way out of the for statement, and eventually when it hits this point right here, is good will still be equal to 1. Now it checks to see whether or not the upper limit is within the proper numeric ranges. And if we've input a value of 12 or something like that, 12 less than equal 2 would be false, 12 greater than equal 20 would be false. I'd have a false, 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 ORed would give me a false, and I would stay out of here. If I enter a value of, let's see, -1, if I enter a value of -1, then it would check to see -1 less than equal 2. That would evaluate true. -1 greater than equal 20 would be false. A true and false would get me into this. If I enter in a value of 21, a 21, let's see, 21 less than equal 2 would be false, and 21 greater than equal 20 would be true. I'd have a false true. That would get me into this. If I enter in a value of 5, 5 less than equal 2 would be false, 5 greater than equal 20 would be false. I'd have a false, false, and it would stay out of here. So any number within range is going to evaluate to a false, false, and stay out. Any number that is out of range is going to evaluate somehow with a false, and I'm sorry, somehow with a true, and because I'm ORing it, will get into this if. So if it's within range, it stays out of the if, and again, it would have a value of is good equal 1. So if it's failed the first test, is good equals 1. If it's failed the second test, is good equal 1. If it fails both tests, is good equal 1. But if it passes both tests, I'm telling you wrong. If it fails either of these tests, is good is going to get set to 0. If it passes both of these tests, is good will remain with a value of 1. And when we get here in the third decision, if it's proven to be a number, every character is proven to be a number. If that number is proven to be within range, is good will have a value of 1, and I will implement the code necessary to generate the Fibonacci sequence. Okay, hopefully I didn't botch that to the point where you can't understand it, but it's important to, see this, I think, because one of the real strengths of JavaScript is that it allows us to check data on the client end before that data is ever transferred to a server for processing. And you see this a lot of times with web forms that you use for commercial purposes. You will fill out a form. In fact, I just did it today. Filled out a form, and I entered in one of the fields incorrectly, and that data was not passed back to the server. Instead, it was inspected on the client machine without burdening the server at all. It was checked on the client machine. It was found to be an error, and it told me there was an error. It pointed to where the error was. I went back in and corrected the field and submitted a second time, and the transaction went through. But any time we can off-bear the processing onto the client computer, then everything operates more efficiently. Okay, so JavaScript is wonderful because you can embed it in web pages. You can do data validation, and once the data has been determined to be, okay, then one time only that data can be transmitted across the network back to the server and processed on the server. And the server never gets bothered having to check to see whether the data is good or not. Okay, I think that pretty much concludes what I want to show you regarding the for loop, and I promise you next time I will look at an example other than the Fibonacci sequence.